Hello and welcome to TidyX episode 105. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. And Tidy Explained is on Twitter at Tidy_explained. Tidy.explained@gmail.com is where you can fire off an email at us, or you can open up a GitHub issue on our GitHub page, or you can subscribe on the YouTube channel. And of course, if you enjoy the series and it's been beneficial to you and you want to support us in any way, we do have a Patreon page, and we are happy and thankful for anything that you can provide.
Yep, we appreciate all the support y'all have given us over the last several years, and in particular recently we had a number of patrons signed up, so thank you all for doing that. So we're doing a bit on objects and kind of getting back to basics. We have gone 105 episodes, and I can't believe we haven't just sat down and talked about what are the basic types of objects that exist in R?
Yeah.
How do they work? How do you interact with them? How do they behave? I mean, we touched on it a little bit in the very beginning, I think, of TidyX, but we haven't really spent time to go back and really explain how all of them work.
Yeah, some of the fundamentals, so to speak. I guess we kind of got off and running with plots, and then that went into stats, and everything that we'll talk about is not anything that is new. It's stuff that we've used across every episode. Vectors and matrices and data frames and calling elements of a vector in every single for loop that we've written on this show is something that we do when we call the ith element within a vector for our loop. So we're going to dial it back and explain exactly how these things work, which is especially beneficial for people that are just getting into R and trying to figure out what the heck this thing is.
Exactly. So hopefully this will be beneficial for you. We're going to only cover a couple of the basic object types. If there's an object type you would like to see us explain, please leave a comment down below so that we can be aware of things that you'd like to see specifically, so we can go over that. So I will share the screen now so that Patrick can see what we're talking about here. I've tried to make us a little bit bigger because this is a little bit of a text-heavy episode here. So here we go. TidyX episode 104, R classes, base object types. So as we talked about last week, R has a really rich object system, multiple object systems that exist in the language itself. So first there's base, which are the objects that come included in the R when you install them, that they're as basic as they get. They are used to kind of build up other object types. S3, S4 are object types that come from the S language that R is based off of. Really great, very useful across the world. R6, RC are advanced, and then of course there's multiple groups in our consortium and whatnot that are looking at new and different object types to try to identify and resolve gaps in the object systems that exist in R. But like we said, what we're going to talk about today are objects. What are they? How do they work? And what are some of those really fundamental objects that exist in R that we use almost immediately when we start programming? So we can go over that. Mm-hmm. So objects. So the way that I like to think about objects, to conceptualize it, is think of an object as a box, right? So a box has its own size and specific contents. Different boxes can contain different things. But then there's boxes with specific properties and behaviors, so there's specific shape, the way that you're supposed to interact with them. Objects have different properties, and this is known as its class. So what is that box defined as? So different boxes can have different types. So think when you're shipping, you can have a UPS box, you can have a FedEx box, and even within those, they have different classes. Overnight shipping, you can have, standard first class shipping, various different shipping types. And so that's kind of how I kind of conceptualize objects. Is they're all boxes, they're all different, they're all defined, but the way that you interact with them and behave with them is different. So I don't know, for some reason that kind of jived with me in the way that I was first learning about objects and how to interact with them. So I thought I'd share that with you. And so in R, there's a number of different base object types that exist, but we're going to talk about 4 here. And I think we talked a little bit about them last week as well. So first, there's logicals or booleans, so that's like a true or false. There's integers, so those are numbers without any decimals, so that's a whole number. So 1, 2, 3, 4, 5, whole numbers. Then there's numerics. So numerics have decimals with them, and they're accurate to the precision of your computer. So like you can have 1.1, 1.2, 1.2, 3, 4, 5, 6, 7, 8, 9, 10. It's the decimal piece that makes it a numeric. And then there are character or strings. They're called strings in other languages. And this is words and numbers within quotes. And so importantly, you need to have these quotes around that for it to be a character. And so this is like saying hello world. And those are a couple different objects that exist. You can enter. There's not much we can do with these though right now because they're just existing. They'll run and they'll print, but they won't do anything to our script. So that's why when we get into scripting, we do variable assignment. Patrick, do you want to talk a little bit about this?
Yeah, so variable assignment is the way in which we assign any of those objects to some sort of element so that we can call it later. And usually this is done in 2 ways. Most of the people in R will do it right there with the little caret and the minus sign. So it's like a little pointer saying, hey, I want to assign whatever it is on the right of this to the element on the left. You can do it with the equal sign. That's more of a Pythonista thing, I feel like. But people do it in R, and it's fine, but it drives me crazy to see it because it's not R-esque, but it works still. It works still. I always think of equal signs as like a math operation, so I tend to not do it, but it works. So like the box metaphor, this is as if you have your box, you're moving to a new place, and you filled the box, and you want to remember, hey, this box contains my kitchen stuff, my pots and my pans and my spatulas and forks and knives and spoons. So this is like writing onto the box kitchen stuff. And you can change the name of the box, but the contents won't change. So here in the example, we have a box that we want to name sample object. And within that box, we have this boolean true. And so if we run this code, we can then go down to our console and type sample object, and we get the contents that's in that box. And we can change the name of the box, so we can call it sample object 2 or something like that. And the contents doesn't change. All that changes is the name of the box. So instead of writing kitchen stuff, we wrote like living room stuff or bedroom stuff or something like that. Yeah,
exactly. So we just assigned it to a new thing. The contents didn't actually change. Our box that held kitchen stuff in it, even though we scratched out kitchen stuff and our living room stuff, doesn't make those contents, the knives, now into a couch.
Yeah. Mm-hmm.
Okay, so those are some basic objects and the ways you can interact with them. Next, we have objects in objects. So those are all of length 1. There's not a whole bunch. They're not much you can do with them. They're not particularly interesting, and you're probably not going to want to have a million different objects of length 1 that you got to interact with. So the next level up are objects in objects. And so conceptually, this is how I think about it. So there's vectors, matrices, and data frames. And all of these store the lower level objects in it as one collection. Mm-hmm. And so once again, continuing that box metaphor, it's more complicated boxes that hold the smaller boxes within them. So it's like your Amazon box arriving and having all the different items that you've ordered together and stored within your object. Mm-hmm. And so the first and most basic type of box that contains other boxes is a vector. So vectors hold other objects. They're stored in a single dimension. So like think of that as like a skinny box that holds a single line of boxes. Actually, as we're prepping this, Patrick had a funny metaphor here of a sleeve of Oreos, right? You have the one line of Oreos that you're all storing together, and that's your vector of Oreos. Vectors are required to have objects of all the same type, so it has to be all Booleans or all numerics or all characters. You can't have a combination of each of them together. And then you say that you're creating a function or a vector using the C function. So if we wanted to create a vector of logical values, use C, and then you have the different object or the different booleans. In here, booleans are only true or false. Here, so now we're assigning true, true, and false to vectors logical. But you can also have a numeric vector of 1, 2.5, 3.141, 5926, 7384. I said that wrong. You can also have a sequence of numeric values. So you can use this colon here. So this is going to say I want all the values between 1 and 10. And we're going to assign that to the numeric sequence object. And then you can have a character vector as well, saying this is a character vector. So this is now going to be a vector of length 5, and it's going to have each one of these elements in there. So we can print that. You can see this vector has these contents.
Mm-hmm.
Yes, there we go. Well, yeah, when you print it looks like that. And then the next level up, so we've been talking about vector, right, which is a length 1, but that's still not particularly interesting. I mean, we use it a lot. It's super useful for us. But the next level up is 2 dimensions. And so those are matrices and data frames. Patrick, do you want to talk us through this one?
Yeah, so the best way to think about the matrix is that it is all contents must be of the same class, and it's laid out sort of similar to this C's Candy box where you have an n by n matrix, an n number of rows by an n number of columns. Again, contents of the same class. So if we scroll down, those are all the same kind of chocolates. The data frame is a little bit different. It's also an n by n square or n by n box of candies, but the columns need to be of the same class. But if we look across the rows, we can see that we have different classes going across the rows. So this is usually the type of format that we deal with our data. If you think of each row as, let's say, a subject or a participant in a study, each column might be like, that's like gender, and maybe it's like age, and then it's, yearly salary and, zip code or something like that, right? So each column is a different descriptor. So across the rows, we have different bits of information that is defined by the columns. That's a data frame. So data frames and matrices look the same in theory, but they hold different bits of data or information. So we can build a matrix by using the matrix function, and then within this, Ellis has a vector which was created above. I think it's just a boolean vector, and he's saying that he wants the number of columns, and that's the thing with the matrices. You can define the number of columns or the number of. You could use n row and say the number of rows. And the matrix is going to know. So it sees if you just define n columns equal 2 or n rows equal 3, it knows that you have 6 elements in that vector. And so it's going to just properly align those with some simple math and say, well, I only have 6 elements. So here's how I do this in a n column fashion. You can also use inside of there's like a by row true or false function. There it is. So then if you make it false.
So yeah, by default, it does it by column.
Correct.
So it'll take these first 3 elements and drop it into the first column.
Yeah.
And these second 3 elements and drop it into the second column. If you say by row, it goes like by row.
Yeah. So this is important. It's important to just know when you're setting up the matrix, because, you like I said, most of the time we're going to use data frames, but if you're doing like matrix algebra and you mess up the way in which the matrix gets laid out, all of the mathematical operation downstream is messed up. So just always be aware. I always check when I make a matrix. I always check, like, am I sure that this makes sense?
Did this get constructed properly?
Yeah. So that's a matrix of logics. Here's a matrix of numerics with n call 3. And then a data frame, like we said, is the most common way that we're going to do things. And here we have different, each of those commas is separating a different column. And here, if Ellis runs this and then runs that, it's going to assign the column names whatever the heck was in each. So you could actually assign the column names within the data frame function and just say like column 1 equals, this, and column 2 equals that, and column 3 equals that. And the data frame is going to produce a nice and clean data frame for you. And again, each of those each of those columns has the same object type, but all across the rows is different. If you were to change an element, so let's say in column 2, we can see that those are numeric. If you were to throw in something like a quote around one of those numbers, and we called string on this, you'll see that R says, like, well, 89 there, it's clearly a character value, so that must be what you want. So just be aware of what's there, and because you have to be aware of this when you read in your data. If you have something funky in one of those columns, and this might be an issue if you're dealing with really big data, sometimes you'll read it in and you'll call string on the data frame and you'll be like, well, that shouldn't be character, and it's just somewhere down there. Someone might have put a quotation mark or a dash sign or something that shouldn't have been there. So just be aware.
Out. Yeah. So R does type conversion, which is converting between these different object types, the base object types. Mm-hmm. It tries to guess and think what makes the most sense here. That doesn't mean it makes the most sense to you in your situation. It is what makes the most sense to the language.
Yes.
Very important.
Yes.
Yes. All right. So now we've got these objects and objects. We've got the vectors, matrices, data frames. We've got the basic objects as well. So now we can kind of like interact with them and play with them a little bit. But what if we want to access content? So what if we wanted to access, the second row and the third column of our matrix or data frame, or the fifth element in our vector? We do this all the time. You can see us doing that in many, many past episodes. And the way you do that is with these square braces here. So in the square braces, we enter another vector. So, super vectors on vectors, everything's connected, man. We can access a single entry or multiple depending on the length of the vector that we enter into the square braces here.
Yeah.
So if we're trying to access an element of another vector, it's a single dimension, right? We only have length of our vectors. So therefore, we only have to enter a single vector to representing the index that we're trying to access here. So we have our vectors logical, right, which is a vector of length 3.
Yeah.
And we want to access the first entry here. So all we do is enter a vector of length 1 that is 1. All right, so we're able to run that, and we're able to access this first entry here, vectors logical 1. If we want to access multiple, you pass a vector indicating the indices that you want. Here, so we're wanting to access entries 2, 3, and 4. When we run that, you'll note that actually vectors logical is a vector of length 3, but it tries to go, it's okay, I know what you're trying to do. You're wanting to access entries 2, 3, 4. Well, I don't know what entry 4 is, so I'm going to drop in an NA. So we've got now entries 2 and 3 and an NA. So 2 and 3, which is true and false, and then an NA.
Yep.
So yeah, so that's how you access vectors. But how do you access matrices? Well, matrices, as we talked about a fair amount earlier, has 2 dimensions, rows and columns, M and N. And so you have to enter, or potentially can enter, 2 different entries here. You may want to access the first entry in the square braces is the row or rows that you want, and the second entry is a column or columns that you want. And so in matrix numeric, which is, this 1 through 9 numeric, and I want to access the first entry in the first column. I run that, that'll going to pull out the 1. If I want to access the first, or let's say the second column and the third row, which should be 8, we can run that, and now we're going to pull out that specific value here. In a data frame, it's a similar concept as well, But if we want to pull out all the columns, but only rows 1 and 2, you leave the second entry. So you say, I want rows 1 and 2, but I want all the columns. And you don't have to type in 1 through number of columns that exist. You can just leave that blank. And it's gonna go, of course. Well, that means you want all the columns. So we're gonna run that. And so we've pulled out from data frame rows 1 and 2. And then if you wanted this time to keep all the rows, but only columns 1 and 2, you can enter in then after the comma, 1 and 2. And there we go. Now we've pulled out call 1 and call 2. You can, of course, subset and pull out row 1, entries 1 and 2. And
you just need the C if you wanted to do, let's say, rows 1 and 3, because there's so do all columns but rows 1 and
right here.
Yeah. Because we only have two columns. Yeah. So let's say it was like 1 and 3. Yeah. There you go. Now you get 1 and 3, and you can see that they're indexed to the left in your console. And if you ever forget, because you're in 2 dimensions here, if you ever forget the commas, and you're just going to get an error.
No, so it's going to assume you want columns at that point. I don't suggest you use this method all the time.
No.
This is kind of an advanced, you need to understand how it all is functioning. This is like a data frame is a unique object, under the hood. So.
You will get an error in line 3 there, though, because you have comma, comma, comma. It's like a 3-dimensional. What do you have there? No, line 3 where it says data frame mix. Yeah, that one. Is that going to kick out an error? Oh.
No. So this is. So there's technically a few more entries in the square braces. So this is going to. This pulled out the first column.
Yeah.
And then this last entry is whether it should drop or not. And it's like, should it?
Yeah. I never use that.
Yeah. So there's this third entry in here. Sorry, we're getting into an advanced R thing here. This is saying whether we should drop its class and have it converted into a vector or leave it as a data frame. And so by default, this is true.
Yeah.
Sorry, we're getting into an advanced thing here. So this is going to drop it and turn it into a vector. But if I don't want it to change, we say false, and it'll keep it as that.
Keeps the column. Yeah, got it. Yep.
All right, there we go. So that was a fun little advanced thing that we just dropped in there. So the final thing that we want to, not final thing, one of the last final things is, okay, now that we can extract stuff, how do you change stuff in an entry? And you can do this with the arrow assignment, just like we assign to an object and assign it a name. We can assign to values in our matrix and vector what we want it to be. And so we specify the elements, rows, or columns that we want to replace. And you can specify a specific entry or an area with a value. So in numeric matrix, here this is going to assign.
Whoa.
There we go. This is going to assign to the first row in all the columns the value 45.
Yes.
And then this is
actually changing the contents in the box now.
Yes.
Before, we were just changing the name of the box. This is actually taking the pillow cushions and saying, I'm going to put the steak knife in here.
Exactly. And then here we're saying row 2, columns 2 and 3, I'm going to assign the value 20. Mm-hmm. And so now we've dropped that in there. Importantly, this is either has to be the same number of elements that you're replacing, or an element of length 1, and that'll replace all of them with this one entry here. So we couldn't say this is 2 elements that we're replacing, right? So the second column, entries 2 or in columns 2 and 3, we could not enter 20, 40, and 50 because this is a vector that's too long. And so it's going to now throw an error. It used to throw a warning. No longer. It will not allow you to do that. But what you can do is this is now the same length, so we can drop that in, and this put a 20 into the first element that you're replacing and a 40 into the second element you're replacing.
Yep. Clever.
All right. So far, the way we've been accessing the different contents is through their indices. And that works pretty well. I mean, as long as you know where everything lives. But sometimes things kind of shift around. Sometimes the data are not formatted the same all the time. There's a number of different ways. So what you can do is vectors, matrices, and data frames can also have names set along their different dimensions. So vectors would have names to represent each element. Matrices and data frames could have names to represent the rows and the columns that you're doing. And it just makes it a lot easier for you to index. So think of, once again, let's go back to our C's Candy example here. We've got this data frame that's got the dark round, the swirled round, the light round, and the swirled square. So this is like kind of earlier when we created the data frame with call 1, call 2, call 3. If we wanted to access a specific column, you pass that name to it. And so if I wanted swirled round from this, I'd do C's Candy Box, if that was the name of the object, square brace. If I wanted all the rows, I'd just enter a comma and then quote swirled round. And it would pull out the second column for me, or I could do index 2.
Yeah, or you could do $, right?
Yes.
It'll pull it out as a vector, but I think...
Yeah, another way that you can access... This code won't run here.
Oh.
Because I didn't create the
Oh, yeah.
But yeah, here's 3 different ways you can access this. So this is going to pull out the second column.
Yep.
This is going to pull out the second column, but we're using the name swirled round in the square braces. Or what you can do is you can use chocolate box and $ and say I want the swirled round column. And those are the 3 different ways that you can play with and interact with a named data frame. And the same idea translates to rows, or for a vector, the elements themselves. You can if we wanted to pull out multiple columns, you can use the named vector. Say we wanted the swirled square as well, you can do that. Unfortunately, this does not translate to the $ notation, but it works like that.
Yep.
There you go. And those are some of the basic objects that exist in R, how you can build them up to form vectors, and then matrices and data frames, how you can assign values and pull values out, which is something that we do literally all the time in every one of our episodes, but we've never actually sat down and take the time to explain that all to you. So let us know if this is content that you found valuable, if this is something you'd like to see more of. What objects would you like to see us cover in the future? There's a ton of different objects that exist in R. There's a million different packages that create their own object types that exist in R, and how you can interact with those. I think we've covered them a little bit in the past. So please let us know what you'd like to see in the future, and like and subscribe down below.
Yeah.
So with that, I think we're going to call it. Thank you all for joining us so much for 105 episodes. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Orr. You can find me on Twitter at OSPPatrick, at Tidy_explained is where the screencast is on Twitter. Tidy.explained is where, at Gmail is where the screencast is on Gmail. You can take up an issue on the GitHub repo. You can like and subscribe on the YouTube channel. And if you enjoy the work and have found it useful and want to support us in any way, we are very appreciative on our Patreon page.
Thank you all so much, and keep on exploring your world.